Hello there, ROS developers, and welcome to this live class number 115, where we are going to see how to remotely connect and control a Jetbot Nano. So let's go for it. Alright, so hello there everybody, welcome to this new live class number 115. And so as I have just said, today we are going to see how to connect remotely to a Jetbot Nano that we have here in our offices in Barcelona. So I'm going to connect to it from the ROS Development Studio and control it. And one of you, or maybe more, depending on the time, we are going to let you also connect to the robot and control it. So let's not lose any more time because we have many things to do, and let's go for it. Before starting though, let me know, as always, let me know here in the chat if everything is fine, sound is fine, image is fine. Please let me know. Engineering Nations says, I can hear you fine, but it seems like the volume is a little bit lower than usual. Okay, let me try to get closer to the mic and let's see if it gets better. Hello there. All good, everything is perfect. Okay, excellent. Then let me know also if you are new to live classes, if you are already veterans, or you are new here, because that's something I always like to know. If of course there are some names that I already know because they don't miss a single live class, which is great, by the way. I love it. Okay. Attended. Okay, so it's the second one for Soham Kulkami. I'm new, says here also Sudarsan. Okay, then let's try to second class also, second one. Great. So some new people here. Then let's go for it. Okay, so as always, as in your case, as I did in the previous live class, I'm going to start by sharing the live class project with you here through the YouTube chat. So that's what I'm going to do right now. Then let me switch to my computer screen here. There we go. And right now I am, as you can see, in the Construct app. So if you are completely new and you don't have an account, just create an account here to the in the Construct. It's going to take you just a few seconds and it's completely free. In case you already have an account, just log in and be prepared. And what I'm going to do right now here is to share the project with you guys. Here I have it. So let me grab here the temporary link and I'm going to share it here in the chat. All right, so I was trying to show a video here, or let me try to do it real quick and see if I can show it in some way. I'm not sure if I'm going to be able. Nick Carter here is saying new. Okay, so once you click on this link or you copy paste it into your browser, you are going to get a message here which is going to tell you that probably you don't have enough space. In that case, you can just click on the Not Now button and click on the Fork button, which is going to allow you to copy the ROS-ject. So you are going to see you're going to see an image similar to this one, showing you the ROS-ject. Yes. So you are going to have to click on the Fork button, which is going to basically copy the ROS-ject into your ROS-ject section, as always, okay? Let me know here if you are getting the ROS-ject copied to your workspace without problems, if everything is going fine. If not, I'm going to try to give you some support so that everybody can get his ROS-ject. So please let me know here in the chat. Okay, I am not getting any message here, so all good, I mean. Okay, so I suppose everybody is being able to copy his ROS-ject properly. I want to take some time on this, so I don't mind spending some time in making sure that everybody gets his ROS-ject, because I want you to be part of this live class, and I want everybody to have his ROS-ject so that you can open it and you can try everything that I'm going to be doing also. So that's why I don't mind taking some time here, making sure that everybody gets his ROS-ject properly. Okay? So, all right, then once you have the ROS-ject here in your workspace, all you have to do is to come here and click on the Run button. Yes, then this is going to start opening the ROS-ject and loading the environment as always. So meanwhile, let me come here. Let me have a quick look at the chat to see if everything is going fine. Nick, all the three links are the same one. So I have shared it 3 times so that it's more visible for everybody, but it's the same link. I have just pasted here 3 times. Yes, exactly, Sudarshan. Once you have your ROS-ject copied here into your workspace, you have to click on the Run button. And then this is going to start loading your ROS-ject. It might take some minutes. Actually, 1 minute, maybe 2 at most, depending on different factors. But right now, here it's loading the environment. So just make sure that you copy the ROS-ject, then you click on the Run button and wait for a few seconds or minutes until the whole environment gets loaded. Yeah? All right, then meanwhile, my ROS-ject is getting loaded. Just I wanted to remind you guys about all our courses. Especially, I wanted to talk about a new course that we published yesterday. So it's super brand new. And it's about reinforcement learning for robotics. So you can find it here in the artificial intelligence section category. And it's a super interesting course, which is going to teach you, it's going to introduce you, and it's going to teach you the most important and most extensively used learning techniques and algorithms which are related to reinforcement learning. Yes, in fact, this is what we based last week's live class, which was a great success. So, so in these courses where you are going to be able to find everything, explain it more in detail with many different ROS examples, a project where you are going to be able to apply everything. So yeah, super interesting course. As I say, it's been published yesterday, so it's super new. So I really encourage you to have a look to it, because I'm sure that you are going to love it. Absolutely love it. All right. So as you can see here, I have my ROS-jet, which is almost loaded here. It's just still loading some features like the shell, the IDE, but it's almost there. So let me see in the chat how you guys are doing. So were you able to load properly the ROS-jet? Yes, no, mine is here taking some time. We are working in a ROS-noetic distribution, so this ROS-jet is based on ROS-noetic, and these ROS-jets usually take a little bit longer than other ones like kinetic or melodic ones. In any case, it's almost there. I'm almost there. So let me load it. Thanks. Yes, I was able to. Okay, great. Yeah, so probably most of you have already have your ROS-jets loaded, which is going to, by the way, open automatically here the notebook. So let's wait, in my case, for my ROS-jet to be loaded. So probably, since we are some people here today, I can see we are 55 students, 55 ROS developers right now. So probably you have taken all the computers and you have left none for me. So I have to wait until my computer gets started from zero. That's why mine is taking a bit longer. Loaded. Can I download all this project and run it locally? Yes, you can, Lucas, if you want. You can download the contents and run it locally. Sure. All right. Come on. It's taking some time to load. Let me refresh and see if this helps the environment. All right. So it looks like today I'm going to be the last one to have the ROS-jet loaded. Let me get a bit of my magic potion, by the way. Okay, so meanwhile mine gets loaded, because the computer has to start and everything. So let me just explain you the structure of today's live class. So basically, we are going to be connecting to a real robot, as I have said in the introduction, which we have here in our facilities. Then in the first part, I'm going to work with the simulation. We are, not me, but we are going to be launching a simulation, a gazebo simulation with the Jetbot robot. And we are going to create a ROS program, a very basic ROS program. You are going to see it and test it in the simulation. Then once we have it running properly, once we know that our program is working in the simulation, in the gazebo simulation, then we are going to move to the real robot. So I'm going to show you here some simple steps that I'm going to be following in order to connect to the real robot from this ROS-jet. So from the ROS-jet that we are working on, I'm going to, using some specific commands that I'm going to show you right now, I'm going to connect to the real robot that we have here in Barcelona. We are going to visualize the real robot also using the lab camera. So let me quickly switch here again to the computer screen. So we are going to visualize the robot here. Yes. So as you can see, I have it already prepared here. The Jetbot robot that we are going to be working with today. Here in the upper left corner. Yes. Here we have in the middle the Tartarbot, but for today's live class we are going to be working with this one. Yeah, we can see there a hand. Probably I don't know who's that. That are very ugly hands. Yeah, but those hands are pointing to the robot which we are going to be working with today. And yeah, so then we are going to test our program, the program that we have created. We are going to test it in the real robot. And then finally, we are going to do, we are going to let some of you, we are going to let you try to connect also to the robot and run your own program here and see how it performs in the real robot here in this live camera. Yeah. All right. So let me go back to my screen. Where do I have? Okay. There we go. Okay, so for some reason my screen is not loading. Probably there's been some kind of error. So let me try to come back here. But because it shouldn't take that much to load, so I think there's been some kind of issue in my project. So in your case, your project has opened properly. I can see some of you has already loaded the project, right? So you have it already loaded with the notebook and everything. Is that right? Lovely Turtlebot 3, yeah. Yeah. Yes, the simulation is running too, so you... Yeah, I don't know what's going on here in my case, because my project is not opening for some reason. Let me try one thing. I'm going to try to load a different project and come back to this one and see if this fixes the issue. Let me try to open, for instance, this one, the project for last week's live class. Let's see if this one loads properly. Okay, sorry for this. So these are the things that usually happen when you are live. That everything starts to fail for unknown reasons. So let's see if this fixes this problem. Because usually this should open without problems. So let's see. Yes, so something is going on here. I don't know. Something strange is going on here. I don't know. Let me try to ask my colleagues if everything is fine with the platform, but I can see that you guys are being able to load your projects. So I suppose that it's nothing related with the Academy. Yeah, let me try what your suggestions to open a new tab. Okay, so I can see that my project has been closed now. So let me try to open it again. Okay, let's try to run it one more time and see if now it works. No, I'm getting this strange gray screen here. It's like nothing is loaded. Okay, let's wait. Yeah, now. Okay, let me check. Don't worry, man. We understand. Okay, thank you, Costas, for your comprehension. Mine look same as his. So Nick, you are having the same issue I am having. You say? So you weren't able to load the ROS-ject neither? All right. Somebody else is having these issues? I'm having same issue, says JF Kidder. Okay. Let me. Okay, so my colleagues are telling me that it might be an issue of time because some new computers were launched in our cloud system right now. So we have to wait some minutes in order to have the computers fully loaded. So that might be the reason. Then probably some of you. Okay, yeah, here I have it. Yeah. So probably some of you got the computers that were already running, but some of us, me, in my case, for instance, and probably others, we were stuck in these new computers that were launched in that exact moment. So we had to wait until the computers were launched to have our ROS-ject loaded. So probably that's the reason. Here I am in the old live class ROS-ject. So let me switch to the new one, which is this one. Let me run this one. Okay, yeah, so it looks like that. It looks like this was the issue. So some new standbys, some new computers were launched at the moment that we were doing this live class. So I had to wait for this computer to completely be started. There we go. Yeah. So now it's working, and now I can properly open the ROS-ject. Okay. So let's see if everybody in the chat has now the ROS-ject loaded. Let me have a quick look here at the. Yes, Nick. Okay, so Is it working for you guys now? For the ones which was still not loaded? Yes, open, yes. Violeta says also yes. Okay. Okay, excellent. Okay, great, then let's go for it. So, let's try to go as fast as possible so that we can complete all the steps. Then, all right, so let's start by opening the simulation. So for this, let me open here a new shell. So here in the bottom menu at the left bottom corner, you are going to see the shell, the web shells icon. So just click here in order to open a new web shell. And here we are going to have to execute this command that we have in the notebook. ROS launch jetdoc gazebo live class 115.launch. Then let's come here and run this command, which is going to basically start the simulation. Then once we have the command running here in the web shell, we are going to click here in this cube that we have also here in the bottom menu. I'm going to click on this cube, which is going to open the gazebo window. For the ones that you have already worked on previous live classes and know ROS-DS. You already know all this, but I'm showing all these steps so that everybody can see what I am doing and following. Then this is the simulation that should be loaded. So here we have the Jetbot robot, and here, as you can see, we have the real robot lab, our lab environment, which, as you can see, it's basically this same environment that we have here. Yes, with all these, the streets, the traffic signals, etc. I can see there that there is a Turtlebot robot which is attacking my Jetbot. So okay, in any case, let's go back to the project. Okay, so here we have the environment, which is the same, more or less the same as the real environment, and here we have our Jetbot robot. Yeah? Alright, then once we have the gazebo simulation loaded, let's open a new shell so that we can start working on a new shell. And then what I'm going to do right now is to create a very simple ROS program. I'm going to create a simple ROS program basically so that my robot can more or less navigate going through these roads here, doing a kind of square-like movement. So this is going to be the goal of my program, of the program that we are going to create right now. So for this, we are going to start by creating a package. Then let's come here to the shell, go to our cacking workspace, src folder, and create a new ROS package. You can copy the command directly here from the notebook. In this case, I am going to name the package lab tests. So let's run this and create the package. There we go. Let me open a code editor, by the way, here. Then now, if I, through the code editor, if we navigate inside the Cacking workspace, we're going to find here our package, lab test, that we have just created here. All right, then next thing to do is to create our Python script. So here inside the lab test package, I'm going to create a new file, which I'm going to name move_jetbot.py. There we go. And inside this Python script, I'm going to copy the code I have here in the notebook. So I'm going to directly copy the code from here and paste it here into my script in the IDE. All right, then let's have a very, very quick look at the code. So as you can see, we are doing some imports of some messages that we are going to be using. Then here we are defining our class, our Python class, which is named robot control. In the constructor of the class, we are declaring a publisher, which is going to publish into this command here, jetbot motors/cmdstr, which receives string messages. This is a topic that probably you are not very used to. So most of the ROS simulations and most of the ROS robots that we have been working in live classes, etc., use the twist message and the command vel topic in order to control the motors and in order to move the robot, right? In this case, this Jetbot robot that we are working with, in this case, we are not going to control, we are not going to move the robot using the command vel topic and using twist messages, but instead, we are going to control the robot using this Jetbot motors topic and using string messages. You can find here, down here, an acceleration of this point. So this topic listens to string messages, and then depending on the string that we put in the message, the robot will perform one movement or another. Then basically you have 5 strings that we can use, which are forward in order to move the robot forward, backward in order to move the robot backward, left to make it turn left, right to make it rotate to the right, and stop to make the robot stop. Yeah? So we are going to control the movement of the robot with these strings, not using velocities or using twist messages in this case. All right? So, having this into mind, we have created a very, very simple program. As you can see here, here we have it. So basically, here we have the main code. So we are going to be moving straight. We are going to call this move straight method from the class. Basically, the move straight method, we have it here. As you can see, we are just sending the forward string to the topic. So by sending this forward string to the topic, we are going to make the robot move forward. Then we are going to be moving forward for 12 seconds in this case. Then we are going to stop the robot, and we are going to call the turn left method, which we have also defined here, which basically it's just sending the left string. So we are going to make the robot rotate to the left, and we are going to keep repeating this. Yeah? So, until we stop the program, of course. Until we stop the program, we are going to keep repeating this logic. Yeah, so we are going to be moving. Let me come here to the simulation. So we are going to move the robot forward for 12 seconds. Then we are going to stop the robot, and we are going to make it rotate to the left. Then again, we are going to move the robot forward. We are going to stop it after 12 seconds, and we are going to make it rotate to the left. Okay, in this case, the rotation to the left, this turn left, as you can see, the movement is for 1 second. Okay, so let me actually, here you are going to find other functions. Also, we have the stop robot function, which sends the stop string. We have a callback function for the dormitory, which we are not using in this case. We have also here a rotate function, which we are not using in this case neither, because this is a much more accurate function that we would be able to use in case that we were using twist messages. But in our case, we are not using this. So I have just left these functions here so that you can have a look at them in case you are interested. But the functions that we are using basically are turn left, move straight, and stop robot. So super simple. We are using the forward string, stop string, and left string. Then let me run this program actually, and see how it performs. There we go. So let me make this simulation a bit bigger so that we can see it better. And I'm going to also restart the simulation. There we go. And let me run very quickly this move jetbot.py. Okay, so the robot starts moving forward. As you can see here, it's going to do so for 12 seconds. Then it's going to stop, and it's going to rotate to the left for 1 second. There we go. It rotates to the left. Okay. And now it's going to crash. Okay, let me stop. Okay, so as you can see, this program is, its logic, it's open loop, let's say. So we are not using any sensor readings from the odometry, from any other sensor. So basically, we are just moving the robot and controlling the rotations and the movements just by time. So in this case, for instance, we can see our goal would be to rotate the robot more or less 90 degrees to the left, right? So that we can face it in this direction. Then in order to do this properly, we would have to check odometry data, etc., and make a kind of control, build a kind of control system so that we can make sure that our robot is rotating 90 degrees. In this case, we are doing it open loop, so we are just going to make the robot turn more seconds or less seconds. So now we have here, we have a sleep of 1 second, so we are making the robot rotate to the left for 1 second. Then, for instance, if we increase this time to 10 seconds, let's try again the program in this case. So let me again reset the simulation. here, and let's run again the program and see how it performs now. So we are moving forward again for 12 seconds. Then we are going to stop here. We are going to rotate to the left for 10 seconds this time. You can see it there rotating. And we can see that, yeah, so more or less we have achieved this 90 degrees rotation to the left. So for this example, we are going to give this as good. So the motion keeps going, the robot keeps going forward for 12 seconds. Now it stops, it's going to rotate for 10 seconds, and then it's going to keep moving forward. And at the end, as you can see, this is generating a kind of square motion, which is going to make my robot navigate along this road until I stop the program. Yeah, so this is the idea that I wanted to generate here. Of course, this is an open loop program, so it's not going to be a perfect rotation, but for the example, it serves its purpose. Okay, so you can, of course, let me stop it now. You can change here the times in the turn, here in the turn left function. You can touch these seconds, and this is going to modify the time that the robot is going to be rotating. Also, you can touch here in this number, in the range, which is going to modify the number that the robot is going to keep moving forward. Okay, so you can play with these numbers. In this case, I'm going to leave it like this because more or less it achieves the square-like motion that I wanted to create. Then, okay, so what else? At this point, I already have the program working in the simulation. I have tested that more or less it does what I want it to do, and that it works. It doesn't crash anything. So now I'm going to try to move this program. I'm going to connect to the real robot and execute this program with the real robot. Okay, so let's move to this step. Then, in order to connect to the real robot, to this robot that we have here, let me actually put it here. Yeah, so in order to connect to this real robot that we have here, I'm going to connect to it using OpenVPN. Yes, I'm going to create a tunnel with OpenVPN. Then for this, in order to be able to do so, you need an OpenVPN configuration file. Then once you have this file, you have created this file, or you have it, you can execute the following command in order to generate the tunnel. Yeah, so you can use this command, OpenVPN, --config, and you put the name of the file here. Okay, so in my case, what I'm going to do right now is to download this file and upload it to my project. Let me do it now in a moment. So let me come here. I'm going to upload, the file to my project. Let me put it here, for instance. So here I have it. All right. So now, as you can see, I have uploaded here into my package. Here I have it. This jetbot.obpn. Yes, here I have all the configuration related to the so basically to the OpenVPN configuration. All right. Then now that I have this file, I can run the command that I have here, which is sudo. I'm going to need permissions for executing this command, so that's why I need to run this command as sudo. Then, once I run this command, now I have created the connection to the real robot, okay? So at this point, what I'm going to do, by the way, is to stop my simulation. So I'm not going to be working anymore with the simulation, so I'm going to just stop it. Let me close it. And now I can see here that I have been tune tab device tune 0, open it. So my connection with the real robot has been successful. In any case, in order to make sure that this has worked properly, we can use the ifconfig command. If I run here an ifconfig command, I'm going to be able, in this case, to see that this tune 0 connection has been generated. Yes, this is the tunnel that has been generated with OpenVPN. So this is connecting me actually to the real robot. Yeah? Then, once my tunnel has been created, I'm going to need to do some extra steps. Let me come back here to the notebook section. Yeah, so with this command, also with the ifconfig command, we can check the tunnel interface, which is this one, and you should, at this point, write down the IP assigned to you. In my case, my IP is 10.8.0.2, as I can see here. Yeah, so here I can see the IP that has been generated, that has been assigned to me, in this case, to my computer. Yes? So now, if one of you tries this, you are going to see that your IP here is going to be different. So take this into mind and make sure to check what is the IP that has been assigned to you. Okay? What else? Then, once the tunnel has been created, I'm going to need to set up some environment variables. Yes, because now, if I try to check here the topics, I'm not going to be able to see them. As you can see, this is saying me, hey, unable to communicate with master. Why? Because my ROS master URI is wrong. It's not pointing to the real robot, to this robot. So I have to modify my ROS master URI environment variable so that it points to the Jetbot robot. Then for this, here I have the command in this case. So I am going to modify my ROS master URI, and I'm going to point it to the IP 10.8.0.1, as you can see here. Why to this IP? Because I know that this IP is the IP of the robot. Yes? So right now I am pointing my ROS master URI to the robot. Yes? To this robot. And this robot has this IP, 10.8.0.1. So that's why I am setting this ROS master URI. So let me run this command. Then finally, I'm going to also set up two other environment variables, which are ROS IP. And in my case here, I am setting my IP, as you can see, 10.8.0.2. And also I'm going to export the ROS hostname environment variable, so that it is pointing also to my computer, to my IP in this case. Yeah. So now that I have set up the environment variables, if I execute again ROS topic list command, now I am able to see the topics of the Jetbot robot. Yes. So now I have been able to check that my connection to the Jetbot robot has been done in a correct way. All right. So, by the way, here we can see the topic, the Jetbot motors / CMD STR topic, which is the one that our program is using in order to move the robot. Yeah. Here we can see this topic. So now let me check the robot. Okay, so here we have our robot. So now we could try to run our program and see what happens in the real robot. Let me try to move this. I don't know if I'm going to be able to. Let me try this. Because I would like to kind of be able to, no, I can't. Okay. Yeah, I'm not being able to visualize it properly. Okay, then let's just try to see it like this in the best way we can. So, okay, yeah, let's run our program. In any case, we have there our colleague Ricardo, which is taking care of the robot. So, in case the robot is going to crash in a very bad way, I hope he is going to rescue it. So let us try to run the program. Then let's come here and run our program, move Jetbot. Okay, so before running it, remember, we should expect our robot to start moving forward here, and then stop after 12 seconds and rotate to the left. So let's run our program and see what happens. Okay, I'm going to run it and I'm going to switch to the live camera stream so that we can see what's going on there. There we go. Okay. I cannot see the robot moving right now. Oh, actually, I had that stopped. Okay. Okay, let me stop. Okay. So I was not seeing it here, but probably you were able to. I had the live stream stopped, so that's why I wasn't seeing nothing. Okay, now I can see it. So I have stopped here the program. Let me actually stop the process. Rep move. Let me kill this. 65, 91. Okay. So this is live now. The robot is facing the right direction. Okay, so let me actually run this one more time and see what's going on with the robot. Let me run it one more time. And now, okay, let me visualize now what's going on here. Okay, so the robot starts moving forward, which is what I am expecting. Then after 12 seconds, the robot should stop and start rotating to the left. Let's see. Okay, there it stops and it starts rotating. Okay, so now I can see that it's rotating more than what... Let me stop the program right now at this point. Let me stop it. Okay. I have stopped there the program. Okay, so what we can see, for instance, is that the rotation in the real robot is much higher than the one in the simulation. So in our simulation, we had the robot rotating for, if you remember, here we have it, 10 seconds. But in the real robot, the velocity at which the robot is rotating is much faster than in the simulation. So we are going to need to adjust this time here. So let's go back to 1 second and make the robot rotate only for 1 second, because as we have seen here from the live, the speed at which the robot rotates is super fast. So let me try to update this here and run the program one more time. Let me actually stop the process properly here. -9, 6, 9, 10. There we go. Okay, so let's see how it performs now. Let me check if Ricardo has restarted the robot's position. Yeah, there it is. So let's run one more time the program and see how it performs now. Let me make this bigger. Okay, so there we have the robot going forward. Now remember, it's going to turn to the left only for 1 second. So let's see if it's better. So the robot is not stopping now for some reason. Oh. Oh, I think I know what happened. Okay. So I had a booking here for my Real Robot Lab, and now suddenly everything, since my booking has finished, all my shells have been closed here unexpectedly. Okay, so let me connect again to the robot. SRC, CD lab tests. Let me here connect to the robot again. Well, let me check very quickly if I am still connected. I don't think so. No, I'm not. Okay, so let me run. Let me see if the connection is still there with ifconfig. Okay, yeah. So the tunnel is still there. So I have the connection is still there. So all I need to do then in this case, I don't need to run again to create again the tunnel, but all I need to do is to reconfigure basically my shells variables. So it's just going to, I'm just going to need to rerun these commands here, and I should be able to keep working with the robot. So let me run this super fast. And ROS topic list to verify that this is working. Okay, it is. Then let me run my code and see how it performs. All right, there we go. Ricardo, can you move it a little bit to the back, the robot? Is that possible? Just a little bit. Oh, it's moving. Okay. One second. Let me stop that process. Rep move. No, actually, I don't have any command. Echo. Let me publish there a command to stop it. Okay, is now the robot stopped? Ricardo, can you confirm? Because I'm not able to see it properly here. Are the wheels stopped? Yes. So the thing is that I am here in my studio, in the studio where we record the live classes, so I cannot see directly the robot. So that's why I am only able to see the robot here from the live stream. So I need Ricardo to tell me all these kind of things. Okay, so now, now we can see the robot there is stopped. So let's try this last time to run the script and move it. All right. So let's run the program. Let's come here and see how it performs now. Okay, so I can see it moving now. Oh yeah, there it is. I don't know why this gets stopped. Okay, so we have our robot moving. It's turning. Okay, great. So now it's doing what I wanted it to do, which is to more or less do this square-like movement. Now it should stop and rotate to the left. There we go. Okay, great. So yeah, as you have seen, we have been able to do this connection to the real robot. There we have it. Still, I think I'm going to stop it because at the end it's going to crash with something. Yeah, let me stop the program. Okay. Just stop there. Yeah, it just stopped. Okay, excellent. So yeah, here we have seen that we have created the program, very simple and basic program, and we have tested this program into the simulation first. Then we have connected using OpenVPN to the real robot, which we have here, and we have done some configuration. Actually, I have not gone too deep into all these configurations here because there are other configurations that need to be done on the real robot side. But all of this configuration is going to be covered, by the way, in this webinar. So Ricardo is going to do this webinar in how to make students remotely access your robots. I have left down here a link so that you can check this webinar's details. And it's very important to point out that in this webinar, you're going to learn how to configure your own robot. So here we are connecting to our robot, to the robot that we have here in our facilities, in the Construct offices. But here, in this webinar, you're going to learn how to configure your own robot. Any robot that you have there, I don't know, in your home, maybe robots that you have in your university, if you work at a university, or in your lab, if you work at a lab. So you're going to see in much more detail how to configure your own robot for remote access. Yes? So here I have left you the link to the webinar details. It's going to be done on the 3rd of March, Wednesday, 6 p.m. So yeah, have a look, and if you are interested on it, here you have the register button. So yeah, that's it. Let me see. Let me go here. Awesome. Finally. All right. So let me. We are already at 7 p.m. But let me ask. Maybe you can answer me here. I don't know if you should try to do a connection with one of the attendants of the live class, even though this is going to maybe take 10 minutes or something like that, more extra. What do you think? Are you would you like to connect to the robot there? Is somebody interested? Let me know in the chat. If nobody wants, then I'm going to finish the live class here, and that's it. I don't know, it's up to you. But if I see that you would like to connect to the Jetbot here and try to run the program yourselves. No, I think we have a shy audience today, so I don't know. I don't know if they really want to try it. Yes. I would like to control it. Okay, let's do one thing. Here in the project, right above the last part here where I have placed the webinar information, you can see an email here, info@theconstructsim.com, and so the ones who are interested in connecting to the robot using this method, send an email right now to this email direction, to this email account, info@theconstruction.com, and put in the subject of the email this sentence: I want to test. Okay? So you write an email with this subject, I want to test, and send it to info@theconstruction.com. Then the first email that we receive, we are going to send you back the VPN file in order to connect to the real robot. Yes? So remember that for all this process, we need to have this OpenVPN configuration file. So for the first one that sends an email to this account with this subject, we are going to send you back the configuration file, the OpenVPN configuration file, so that you can connect there from your house, from your project, to the IgnisBot robot, to this robot. So go ahead, I'm going to give you 1 minute. Okay, so I'm waiting here for Ricardo. I sent the email, okay? So let's see which one was the first one who sent the email. Ricardo is right now checking the email to see which one was the first email received. And he is going to reply to that person, and he's going to send you the OpenVPN file, okay? Kumar Ramesh was the first one. Okay. So remember, he's sending the config. Okay, so Kumar Ramesh, congratulations. So you're going to receive now in your email the OpenVPN configuration file. Yeah, so remember the steps I have just done. So once you have this jetbot.ovpn file, you are going to have to upload this file to your project. Very easily, you can upload it wherever you want. For instance, here inside your Kakin workspace, you just right-click here in the folder and click on Upload Files. Yes? Then in Upload Files, you select the OpenVPN file that we have sent you through email, and then you're going to upload this file into this project. Then once you have the file in the project, you have to execute the command that we have here. Yes, sudo openvpn --config and the name of the file, which in this case is just jetbot ovpn. All right, then this is going to generate the tunnel. Then once the tunnel is created, well, first of all, let me check here, and let's go step by step. Okay, so Kumar, once you have the file, once you have received the file and you have uploaded the file to the project, let us know here, so that we can go step by step, guiding you. I can show you the step by step so that you can connect to the robot. Let us know here in the chat so that we know how you are doing. Wherever you want, Kumar, wherever you want. For instance, place it. I have placed it inside Kakin workspace, SRC lab test. Inside this package I have created, I have placed it here. But you can place it in the SRC folder directly, in Kakin, wherever you want, you can place it. Just know where you place the file, okay? So once you have uploaded the file to the project, Kumar, let's say that you have uploaded the the file in the same place as I have uploaded it, which is here in the lab tests package. Then you come to this folder where you have the file, where you have the Jetbot OVPN, and you execute this first command: sudo openvpn --config and jetbot ovpn. Okay? Then once you execute this command, please execute also an ifconfig command here to make sure that the tunnel has been created. Yes? So you should see this tun0 interface here at the end when you execute the ifconfig command. Okay? Can you confirm that you can see this interface, the tun0 interface, the tun0 connection? Can you confirm it? Okay. Kumar is following. All right. So, a reminder, we run this command, sudo openvpn --config jetbot.ovpn, and then we check with the ifconfig command that the tunnel has been created. Yeah, you should see this tun0 here appearing, which indicates that the tunnel has been created properly. Yeah? Yes, I have tun0. Okay, excellent. Excellent, Kumar. Now, next step. So once you have this, it means that you have created the tunnel. Yes? So you have the connection through OpenVPN from your computer to the robot here in our office. Yes? But now, open a new shell. So now, open a new shell and try to run the ROS topic list command. So probably you are going to get the same error message. Yes? You're going to see an error message which says unable to communicate with master. Then in order to properly connect to the robot, you need to set up the following environment variables. So the first one is this export ROS master URI, which is going to connect you to the robot. It's going to point your ROS master URI to the robot. So this first export command, you can copy and paste it directly. Yes? This export ROS master URI is pointing to the IP of the robot, so you can run it directly. Then these two other commands, which are the export of the ROS IP and export of the ROS hostname, as you can see, the IP is different. It's 10.8.0.2. But this number, in my case, it's like this because it's the IP I have assigned here. So in your case, you should check here in your tun0 configuration, you're going to see that you have an IP here. Yes, in my case it's 10.8.0.2, but in your case probably it's going to be different, this number. So you need to get the number you have here and put it replacing this number in ROS IP and ROS hostname. Okay? Then once you execute the three commands, you are going to be able to run ROS topic list, for instance, and see the topics of the robot. Yes, got the error. Okay, so let's go for these steps. First of all, set up the ROS master URI variable, which is the same command that you have in the notebook, the same one. I have the same IP. Which IP you have, Kumar? 10.8.0.2. So you have this same number here. In the tune 0, you have 10.8.0.2. Yes. Okay, then run the commands. Then run these commands, set up the ROS IP and ROS hostname, and try to run the ROS topic list. And if everything is okay, you are going to be able to see the topics from the real robot, which are these ones here. Yes, I can see the topics now. Okay, great, Kumar. So you are connected to the robot. So right now you are connected to the robot. So you can run your program, this one, the program that we have created, the Move Jetbot. You can run it. You can try it yourself. So now, if you run the program, you are going to start moving the robot. So now the robot is totally yours. So try it. Try to run the program, your program, and let's see if you don't break the robot. Hopefully not. Let's see if we can see it here moving. Yes, yes, Kumar, yes. You can run the Python script. Run it. Go ahead. So I'm waiting here until you run it, so that I see the robot moving. Let us know when you run it. Kumar. Go, Lil Jetbot. Okay. Let me refresh this. No. Not moving yet. No movement yet of the robot. Run the script. Okay. The robot is not moving yet, though. So did you run the script from the same shell where you set up all the environment variables? So remember, you have to run from the same shell where you have set up all the environment variables and everything. Okay, Kumar? Yes. Okay, so no movement for the robot for some reason. Yeah, so this is the bad thing, that we cannot help you much more here, because we will need to access your computer and everything to see better what's going on. Okay, let me try to connect myself one last time. I'm going to kill mine. 5122. Yeah, so the robot for some reason is not moving in your case. I have closed my connections and everything. Let me try to run it again and see. Sorry. Okay. Okay. Okay, so I have closed all my connections now. Okay, I have closed all my connections. So could you try, Kumar, to close your connection and restart it? So basically, it's just as I have just done here. Stop. So stop here the shell where you have the connection running. So now, if I do a if config, I don't have anymore, as you can see, I don't have anymore this the tunnel here. Yeah, I have the ETH0 and LO, but I don't have the tunnel. So I have closed my connection. So in your case, do the same, please. Close your connection and do it again. And try to connect one more time. Just like this. Wherever you have this command running, stop it. Just stop it wherever you have this command running, and that's it. The shell where you have this command running, Control C and stop it. And that is going to close the tunnel. Okay, then just relaunch it again. You start again the command and check the if config IP. Make sure, check which is your IP, and then run again the export commands. And the ROS IP and ROS hostname, putting your IP, the IP that you see with the ifconfig command. Okay, so repeat all the steps one more time. Let's try this. Let's try to finish this live class with this working. It would be amazing. So let us know how you are going, please, Kumar, so that we are now all, all watching you. I stopped that shell. Okay, great. But when I execute ifconfig, my tune0 is still visible. Okay, then maybe you should try this command. Try this command. Try this command. I have pasted here in the chat right now, Kumar. PS Faux grep OBPN. This is going to provide you basically this is going to provide you the process ID number. You're going to probably have some process here laying in the background with the OBPN client running here. So you are going to need to stop it by killing the process. In any case, I don't know if maybe this is getting too complex for doing it here and everything remotely, which is much more complex. Nick, I suggest you to create the file using the IDE. So if you open the IDE here, you can create new files here with you right click in any folder, new file, and this is going to allow you to create a new file. And then you can copy paste very easily here. So you can treat here your files in a graphical way. So not through the shell, which is always much more complex. So you can, I suggest you to create the files and copy paste and everything using the IDE, which is much more easier. Okay, then you have to kill it with sudo, Kumar. You need to do sudo kill whatever. With sudo is going to allow you to kill it. Yeah, second tab, it's this one here. First one is shell, these are the shells, and this one is the code editor. Here you have the code editor. So unless you really know what you are doing, it's always easier to work through the IDE. I always, especially when I am creating code and programs, I always try to work with the IDE because I feel like it's much more easier to program in the IDE than doing all the code modifications and everything through Beam or V. Okay, no more tune0. Okay, great, Kumar. Then now launch it again. So all this to kill it and everything to launch it again. Okay, so now run again the command. Let's do one last try. If this doesn't work, we are going to close the live class here, but let's try it one more time. So let's run it again. Run. Then once you have this command executed, remember to run also ifconfig and check your IP. Super important, this step, to check your IP so that you can use this IP in the export ROS IP and export ROS hostname commands. Yes? The first one is always going to be the same IP because it's the IP of the robot. So this one is not going to change. The one for the ROS master URI. But for ROS IP and ROS hostname, you need to put the IP that you have in the ifconfig, in the tune0 interface. Which IDE you mentioned? It's this one. Here, Nick. Here in the bottom menu. Here in the project, in the bottom menu, we have some icons here. At the left bottom side, there are some icons. Yes, then the second one here, the second, it says code editor. So if you click in this code editor, this is going to open the code editor, which I have here opened. Then here you can create files, you can delete files, you can create folders, you can manage everything in a graphical way. Here. See, so you can create new files, name them as you want, test. Yes, and then you can code here, whatever. So how are you doing, Kumar? How is it going? No robot moving yet? Okay, great, Nick. No worries, no problem. Yeah, that's normal. Yeah. So you need to get used to all of this. So here we have the shells, the web shells, we have the code editor, the notebook, Gazebo. There are also graphical tools, but I'm not going to go into this right now. So yeah, you can investigate by yourself here. Almost there, redoing the steps. Okay, great. Let us know when you run the Python script so that we can see the robot moving. Okay. Remember, super important, once you have established the tunnel, remember to run the ifconfig program and check your IP. It's the one that is going to appear here. The first IP. And you need to use this IP for the ROS IP and ROS hostname variables. Yes? The first command is going to be always the same since you are just using the IP here of the robot, which is the same. I opened it and got the editor making the file. Now working how to figure out how to paste stuff in. Super easy, Nick. You just select whatever you want here from the notebook. Like this, you select it. And then you can right click, copy, and then right click in the file and paste. You have it here. Or the shortcuts, which are Control C from your keyboard and Control V. Okay, let me see here. So how it is going, Kumar? Any news there? Have you run the script already, or? I can see the ROS topic list. Okay. So let's go for it. Try to run the Python script now. Could you tell me once again which shell I should run the script in? In the same one? Yes, it's in the same one where you have set up all these environment variables, where you have executed all these exports, export ROS master URI, export ROS IP, export ROS hostname. You have done the ROS topic list after this. So in the same shell, run the Python script there. In the same one. Don't open a new shell or anything, just in the same one where you have executed all these commands. You can do it, Kumar. Yeah. Let's give some support to Kumar. Okay, running it now. Let's see if the robot moves or not. Yeah, there it goes. There it goes. Kumar, you are moving the robot. There we go. There it stops. It turns for 1 second. Great, great. So we have it. We have. Where are you from, Kumar? By the way, just to know, because you are controlling your robot there from India. He's from India. Okay, great. So yeah, you are controlling, and now it's going to crash again this stop sign. And no worries, no worries. We have Ricardo there to save the day. Okay, so great. So we have been able to finally achieve this, which is super cool. So thank you very much, Kumar, for your patience and following our instructions. Thank you very much. And yeah, thank you all of you guys, because I can see that we are still more than 30 people here, which we were all of us waiting for Kumar to control the robot here in Barcelona from India. Yes. So yeah, remember this. So he's right now controlling the robot from India, and he's moving here a robot that we have here in a room in Barcelona. So it's amazing. It's amazing. Then thank you very much. Thank you very much, everybody, for attending this live class. And remember, if you want to learn more about this, if you want to go deeper and learn more details, especially in how to configure your own robot to be able to achieve this remote access, we have the webinar, okay? It's going to be, it will be in the 3rd of March, if I'm not wrong. Yeah, the 3rd of March. So I have left the link here. You can check all the details. And one last time, thank you very much, all of you. Let me change to my screen. Thank you very much, all of you, for being here with me for almost 2 hours. So 1 hour and 40 minutes already. So thank you very much. And yeah, I will see you next Tuesday in the next live class. Until then, as always, take care and keep pushing your ROS learning. Bye-bye. What are you doing, Alberto? I'm training this intern with ROS.
Oof. Did you have the same experience? Spending too much time equipping your team with ROS skills? Check out our ROS Online training solution for enterprises, a fast and easy way to empower your team with ROS.
From ROS basics to manipulation, perception, AI, ROS2, everything your team needs to learn is here. Practice with real and simulated robots. Train your team by doing from day one. Also, our ROS experts will provide you 1 hour of consulting services to boost your robotics projects.
Want to become a happy Alberto? Request a demo today.